Welcome to Mastering Solutions. In this impulse and momentum problem, we'll be calculating what the impulse is to the spores and the average force of the spores. So the impulse is J, and the average force will follow after we get the impulse. So if we write down our variables in this problem, we know that the mass is given as 1.4 micrograms, which obviously is not in SI units. So that can be rewritten as 1.4 times 10 to the negative 6 grams. And we know that in 1 kilogram, there is 1,000 grams. So now if we divide that, we're essentially moving the decimal place over another 3, which is going to give us 1.4 times 10 to the negative 9. We started with negative 6, add another negative 3, 10 to the negative 9 kilograms. Our next variable is given as the velocity is 4.5 meters per second, and that's technically the final velocity. The initial velocity is going to be 0 meters per second. The change in time is given as 1 millisecond, which is the same as 1 times 10 to the negative 3 seconds. So now let's write down the equation that we need, which obviously is J, and that is the change in momentum, which is P final minus P initial. And J, if we break up the momentum, is mv final minus mv initial. But we already discussed that the initial velocity is 0, so that goes away. And all we're left with is the impulse is equal to the mass times the final velocity. So as we plug these in, J is equal to 1.4 times 10 to the negative 9 kilograms times by the velocity of 4.5 meters per second, 1.4 times 10 to the negative 9 times 4.5 meters per second. Let's change that to scientific notation. Okay, so now when we put in a second answer, that gives us 6.3 times 10 to the negative 9. So J is equal to 6.3 times 10 to the negative 9 kilograms times meters per second. So now we have the impulse. Now we need to find the average force. And we know that the average force is from impulse equals F average times the change in time. So now we just have to isolate the average force. So we divide both sides of the equation by time, divided by time, and that gives us F average is equal to J divided by delta T. So F average equals J, which we just found as 6.3 times 10 to the negative 9 kilograms times meters per second, all over the change in time, which was 1 times 10 to the negative 3 seconds. And we can plug this into the calculator, but we're dividing by 1. So we're just changing the exponent is all. So 6.3 times 10 to the negative 9 divided by 1 times 10 to the negative 3. So it's 6.3. Average force is equal to 6.3 times 10 to the negative 6 kilograms times meters per second squared, or newtons.